Hey, in today's lesson we're going to talk about solving equations that have variables on both sides of the equal sign. Solving these is really just about the same as solving any other equation. The one thing that's new is you do have to get all of the variable terms to one side of the equation. So as far as what to do, your first step is still going to be simplify. That's only if needed. And that would be if you need to distribute anything, if you need to combine any like terms. Now remember that equations have two sides, and so the 7x and the 12x are not on the same side, so we can't put them together to be 19x. So the second step is where things are different, and this is where you have to get all variable terms to one side. And so in this problem, I have a 12x on the left and I have a 7x on the right. My suggestion is always to move the term that is the smallest. And in this case, of my two variable terms, 7x is smaller than 12x. So what I would do in my second line here, on the right side, I would do 7x plus 11, and I would subtract 7x. And then I would go to the left side and I'd do the same thing. I'd have 12x minus 15, and I would take 7x away. Okay, what this does is eliminate the x term on the right side. I would have just 11. And on the left side, I would now have 5x minus 15. Okay, at this point, you're ready to just continue solving the equation. You can use properties of equality. Solve. So once you're there, it's just generally going to be just a two-step equation at most. So in this case, we would just add 15 to both sides. That's going to leave you with 5x is equal to 26, and then divide by 5 on both sides, and then your answer would be 5 1/5, or 5.2. At this point, make sure you check it. It's a little tougher to check things. You would have to put 5 1/5 into the left side for x, see what that equals. You would then have to put 5 1/5 into the right side of the equation and see what that equals. If you get the same thing on both sides, then that would mean that your answer 5 1/5 is correct. So remember the stuff in red, those are steps that would be able to get skipped. So you would have the original problem, and then the stuff that's in blue, that would be the minimum I would expect to see when you're solving an equation with variables on both sides. This particular problem I didn't need to simplify because the left side and right side both had two terms, one variable term and one constant. Hey, linear equations do not always have one solution. Hey, there are two types of these equations. One of them is called an identity. An identity is an equation that's true for all values of the variable, so that no matter what number you put in for x, you would always get a true statement. So all real numbers would be a solution. And the second type is an equation that has no solution. An equation that has no solution, that just means there's no value for the variable that would make a true statement. So no matter what number you would put in for x, you could never get the two sides of the equation to be equal to each other. And I have two more examples left. We'll work through these, one of them for each type. One will be an identity and one will have no solution, just to show you. Remember this first one that I did, that one there was a solution. 5 1/5 was the solution. But now we're going to do some that don't have solutions. So the first step, again, you got to simplify. So on this one, we're going to distribute 15x minus 33 plus 2. And 7x and 8x make 15x, and I have 15x minus 5. And I need to combine here. My negative 33 plus 2 would be negative 31. And that's 15x minus 5. That's the simplifying. Okay, that's the first thing you always do. Second thing you're supposed to do is get all the variable terms to one side. Well, if you look at this one, you'll notice that you have 15x on the left and you have 15x on the right. I suggested earlier you move the smaller one. Well, these are the same. So the way I'm going to move it is subtract 15x, and I would do it from both sides. Once I take away the 15x from both sides, I end up with negative 31 on the left and negative 5 on the right. Right, well, negative 31 does not equal negative 5, so that statement is false. And whenever you get a false statement, right, the variables have disappeared, and my statement at the end is false, hey, this actually means there's no solution. That there really is no value we could put in for x and make a true statement. And probably the easiest place to see that is right here, and I'll mark with the green arrow. You look at that, it says you're going to take whatever x is and multiply it by 15. You're going to do that on both sides. But on the left, you're going to subtract 31, and on the right, you're going to subtract 5. It makes no difference what we put in there for x. There's no way that those two things are ever going to be equal, because the 15x is going to be the same thing no matter what number we choose for x, and one's subtracting 31 and the other is subtracting 5. So this is an example of no solution. What happens when you have an equation that ends up with no solution is the variable terms disappear when you collect them on one side, and then the resulting numbers are not the same. And depending on if you've chosen to move those numbers, you might have something different than negative 31 equals negative 5. Somebody might get negative 26 is equal to 0, or you might get 0 equals 26. All of those are false statements. So the key is a false statement here means no solution. Okay, so a false statement there, that's the statement that told us there would be no solution. And the next one, same thing, I have to simplify. So the left side is 8x plus 6, no simplifying needed. Distribute the 2 on the right side, and you get 8x plus 6. If I then go to collect all my variable terms on one side, I have 8x on the left and 8x on the right, so I would subtract 8x. And when I simplify that, I end up with 6 is equal to 6. Okay? And that's a true statement. Okay? And what that means is this equation is an identity. And as an identity, that means that my answer would be all real numbers. Because all real numbers will work. Makes no difference. And again, it might help to just look right there. Both sides of the equation are going to take the value you think is the solution, whatever number you pick for x, and multiply them by 8, and then you're going to add 6. So you're doing the same thing on both sides, and that's what makes it an identity. So for this, a true statement here means that it's all real numbers. It means you have an identity equation and all real numbers work. So when you're solving equations with variables on both sides, it's important to remember that sometimes you will get one solution, like our first example, but then other times the variable is going to disappear and you'll either get no solution because you got a false statement here, or you'll get all real numbers because our statement was true.